So welcome to the computer architecture course. This is the first day of this course. Actually, today is the first day of the spring semester. And unfortunately, we need to meet using the Zoom online meeting tool. Actually, the university decided to provide the in-person lectures during the spring semester, but as you know, recently the COVID-19 pandemic situation is severe. So actually, it's crazy. So actually, every day more than 0.2 million people are tested positive. So it's crazy. So actually, I hope to meet everyone in person during for this course, but as you know, so actually for the first 2 weeks, I will provide the online classes only. So it's a university's decision. I believe it's college's decision, maybe. Okay. So, okay. Anyway, welcome everyone. So this is the computer architecture course. So this is the mandatory course for computer engineering department, and I believe so someone is maybe interested in computer architecture area, but many of you take this course because this is the mandatory course in computer engineering department. So anyway, okay, welcome everyone. So this is a very important course for the student who want to major the computer engineering or computer science. Okay, because if you study computer engineering, so you need to understand how computer works. So that means that how your program works on computer hardware. Okay. So this is the first day of this course. So I will introduce about this computer architecture course. Okay. So what is the object of this course? So object of this course is that so we will explore computer system architecture at an abstract level. Okay. So you need to focus on this terminology, abstract. So what does abstract mean? So this is an English course, but you can answer in Korean. Okay, abstract means 추상화 in Korean. So abstract means that, so this is the difficult. So this is the somewhat so you are trying, so let us suppose that you try to investigate some very new things, but this new thing it's not easy to understand. So because the mechanism is so difficult, and then so actually below this of a certain system, this system is very complicated system. So it's not easy to understand. But if you want measure some area of the system, then you need to understand how this system works, even though the system is very complex or complicated. So abstract means that we simplified this system. So it's not easy. So it's very difficult to the entire things of this system, but we just focused on a certain level of the system, and then we simplified this level, and then we try to understand this simplified concept of the system. Okay, that is the meaning of abstraction. So what is the abstraction of the computer system? So actually, the computer system is hardware. So, and then I believe everyone knows that the computer system has CPU, that's the central processing unit. And then CPU is like a brain of our body. So actually the CPU is the semiconductor chip, okay? And then, so that means the electric signals moving around inside of inside of this CPU, and then the CPU generates some electric signals. That means the electric data. But it's not easy to understand. It's very complex. So we just simplified this some structure of a CPU or processor or computer systems, and then we try to understand how this simplified concept of computer system works. Okay, that means that that is the abstraction level of the computer system, and we will learn how to understand the mechanism and then the structure or architecture of the computer system at an abstract level, not an entire level. Okay, so this is the object of this course. And then, so what did we cover in this course? So we will learn about the basic concept of computer systems. So as I mentioned, so I believe most of you are computer engineering students. So I believe, so you need to write your own program. Also, you need to develop some applications. Also, you need to also study some hardware of the computer system. But you need to know how computer works. Why? Because we need to use computer systems, okay? And then actually every software or every application runs on computer hardware. So in order to develop the good applications or in order to develop good programs, you need to understand how computer system works. So in this course, we will learn about the basic concept of computer systems. So, and then briefly, we will learn about the performance metrics. So what is the performance metrics? So performance means that how computer system run our applications fast or slowly. Okay, so performance means that performance is very tightly related to the execution time of your application. So actually performance is a very important metrics in the computer systems, because everyone wants good computer systems or better computer hardware. So that means that it's fast computer systems. So in chapter 1, we will learn about the performance metrics in computer systems. So that means how to measure the performance and then how to compare the performance of different computer systems. And then in chapter 2, we will learn about the instruction set architecture. It is called ISA. So this is so actually in chapter 1 is the introductory chapter. So I believe everyone can understand how to measure the performance of the computer system, because I explained that the performance of a computer system is tightly related to the execution time. And then everyone can understand the execution time, right? Because it's fast or slow. But in chapter 2, we will learn about the instruction set architecture. So this is the main area of computer architecture. So actually the computer is a machine that execute instructions. So instruction means 명령어 in Korean. So if you give some instructions to computer hardware, then this computer hardware do something defined by these instructions, right? So instruction set architecture defines the instructions that will be understood by computer hardware, okay? So this is the main area of the computer architecture. So in chapter 2, we will learn about the instructions and instruction set architecture called ISA. Then in chapter 3 is the very short chapter. And then in chapter 3, we will cover the arithmetic logic or number systems in computer processors. So this is the, actually, if you took the digital logic design course, then I believe you already learned about the arithmetic logic or number systems. So this is somewhat reviewing chapter. And chapter 4 is very important chapter in this course. So we will learn about the pipelining, okay? So, and then actually we will learn about the in-order processor architecture. So in chapter 4, we will learn about the hardware architecture of simple processor. So I mentioned that processor is a hardware. So actually, we need to implement this processor chip using some semiconductor materials. Okay, and then this CPU is a kind of digital system design. And then in chapter 4, so you will learn how to build very simple. It's a very simple. So you need to learn how to build very simple processor architecture. Okay, it's called in-order processor architecture. Okay, and then in chapter 5, we will learn about the memory hierarchy. So it's called the memory systems. So what is the memory? So usually, if we mention the size of the DRAM or size of the memory in our smartphone or size of the memory in our laptop, so actually, if we mention memory in computer systems, that means DRAM. So okay, so it's the main memory actually. So, but in the computer system, there are different levels of memory components, and then we will learn about these different levels of memory hierarchy. So it's very important because the performance of a memory system really determines the performance of entire computer systems. That's why also very good memory is very critical for the performance of computer systems. Okay, and then so actually this one is chapter 2, chapter 4, and then chapter 5 are highlight chapters of this course. So, but but you need to also understand the performance or some this real basic hardware, and then also some you need to understand about the parallel process architecture. But the main chapters, so main topics you need to learn in this course are instruction set architectures, ISA. So, or that means the instructions in computer systems, and then chapter 4, the pipelining in the process architecture, and memory hierarchy. These are the highlight chapters in this course. Okay. And then okay, next. So this is the textbook of this course. The textbook is computer organization and design, and then the abbreviation form I frequently call this is the COD, code. And then in this course, we will learn about the RISC-V ISAR. So actually in the previous slide, I mentioned the ISAR. ISAR means the instruction set architecture. And then in this course, we will learn about the RISC-V ISAR. So what is the other popular ISARs, instruction set architectures? ARM, right? So ARM is very popular. So actually, we used ARM architecture or ARM processors for smartphone or tablets, and then also we can use these ARM processors for our laptop computers. And then another popular ISAR is x86, right? Good. So x86 architectures is developed by Intel. Also, it is developed by AMD, another x86 processor manufacturer. So actually, we use the x86 processors for high performance computer systems such as servers, and then also we use these x86 processors like Intel CPUs or AMD CPUs for our laptop or desktop computers. Okay, but for this course, we will learn about the RISC-V. So actually, the RISC-V was invented by the very popular, actually, this person, the author of this textbook, David Patterson and John Hennessy. So Patterson and Hennessy are actually very popular researchers. Then actually, it's a legendary researchers in the computer architecture research area. Okay, and then actually, this person invented the first RISC architecture. It's called MIPS. So actually, the John Hennessy invented MIPS architecture. So this is, but recently they also developed the RISC-V ISAR, and then this RISC-V ISAR is the open source ISAR. So what does that mean? So we can use this ISAR without any cost, but that means that so any royalty. So what does that mean? So if a processor manufacturer wants to build a processor using ARM ISAR, then so this manufacturer needs to pay royalty, the money, to ARM, because the ARM ISAR is maintained by ARM, so ARM, but RISC-V is developed by these. Actually, those persons are professors at UC Berkeley and Stanford. So then they developed the open source. So we don't need to pay royalty, even though this processor is built based on the RISC-V ISAR, and then the process. So some manufacturer wants to sell these processors, but they don't need to pay royalty to this RISC-V foundation actually. So this RISC-V was developed by some academic research labs, and then we can use this RISC-V ISAR without royalty, and then also many researchers in academic communities provide some very useful tools for this RISC-V ISAR. So for this course, we will use this RISC-V ISR for understanding the computer system architecture. Okay, so it's very critical. So you need to read textbooks. So actually, I know the textbook is not cheap, so it's expensive, but please buy the textbook, and then please read textbooks. It's very important. Okay. So we I will post the lecture slides for every chapter. So I will use the additional course material and or tools. So I will post the lecture slides for every chapter, and then we have design labs. And then in this design lab, you will be required to design very simple pipeline processor with system value HDR. So in order to simulate this design, then you need to use the simulator. Okay, so we will use the ModSim. So and then it's the bundle software of the Intel FPGA Starter Edition. So we'll use this ModSim tool for our design maps. And then also I will introduce some architectural simulators for RISC-V during this course. So these are some required material for this course. And then additional material. So if you feel difficult reading some English book, then you can buy a Korean book. It's called 원리부터 설계까지 쉽고 명확한 컴퓨터 구조. So it is written by Professor Sir. Actually, it's a very popular professor for this computer architecture course. Yes. So if you want read text, it's an original book, not the translated book. But if you want understand if you want to read some computer architecture book in Korean, then I recommend this book. This book is very well organized and well explained for the RISC-V computer processors. Okay, so if you struggle to read the English book, then you can buy this book. Okay. Then another additional material is the design and computer architecture, written by David Harris and Sarah Harris. Okay. So, and then if you don't have any background or in the digital design or logic design, and then if you did not take the digital logic design course, then you can read this book, Digital Design and Computer Architecture. And then if you read the first few chapters of this book, then you can cover some digital logic design course. Okay. Okay, authors. So it's the very old photos of the authors of this textbook. So you can find this book is a computer architecture quantitative approach. Okay, this is another very popular book in the computer architecture course. And this is these are this book is also written by same authors. Then so recently, so this is the recent photos of the authors of the textbook, and as I mentioned, these authors are legendary people in computer architecture. Okay, because these authors invented RISC. So RISC means the RISC type computers. And then actually the most of processor in our world use the RISC type processors. Okay, so these are very legendary people, and then this is the recent photo of the David Patterson and then John Hennessy. Also, these are the recipient of Turing Award. So Turing Award is like a Nobel Prize in computer engineering or computer science area. So these are also those people are also recipient of the Turing Awards. And then if you click the Turing lecture video link, then you can also watch the lecture video by David Patterson and John Hennessy. Really good lecture. Okay, prerequisite is the logic design. And unfortunately, the logic design is not a mandatory course in computer engineering. So I believe part of you already took this course, but someone did not take the logic design course. But unfortunately, we need to use the knowledge covered by this the logic design. And actually, so we have design labs, and then for these design labs, you need to know how to use hardware description languages like system Verilog. So the knowledge on digital logic design is required for the processor design labs. And then if you did not take the digital logic design course, then please review please read the where is it? Sorry. Sometimes Zoom it's not easy to use because okay, so can you see my slide, my screen?
Yes.
Okay, thank you. So sometimes so actually I showed my presentation show, but if the show is turned off, then Zoom lost some resolution information. I don't know why. Okay. So okay. So if you did not take the digital logic design course, then please read this book, Digital Design and the Computer Architecture book. And then also actually, so we will start with a very simple design, like so end gate design or gate design for the first lab, but try to review how to use the HDL before doing some design labs for this course. Okay, and then another prerequisite, another required knowledge for this course is the programming languages, especially C, not Python. So actually the C usually C programming language is more difficult than Python, but the computer system, actually the operating system, the very popular operating system is developed using C. So actually the computer hardware, so in order to understand the computer hardware, and then you need to understand the C programs. Okay, so these are the required knowledge for this course. And then me. So my name is Konjaku, and then this is my office, and then it's the office hour, and then so we can meet in this at my office by. So please stop by my office after make an appointment. Okay. And then this is my email address. And then if you are interested in my research area, then you can visit my homepage or lab homepage. Okay. And then my research area is computer architecture. And then I also focus on the research on process architecture, memory and storage systems, accelerators, or secure process architecture. So if you are interested in these research areas, then you can email me or you can contact me. Okay. Okay. So for this course, we will use the Blackboard, like so Korea University Blackboard, and then we will use this Blackboard for announcements, assignments, and quizzes. Okay. And then, but this Blackboard tool is not used. It's not easy to use, so we will use the Piazza for this course. Okay, so this is the information for the Piazza for this course. So if we use this URL, and then you can register to Piazza for this computer architecture course. Then you need the access code for sign up. So access code is the Elder Lake. So this is the most recent Intel CPU code name. So you need to sign up for this Piazza course. Okay. So this is the access code. Please join as a student, not TA or not a professor. And then on the Piazza, you can post any questions or any answers for these questions. So usually the students post the questions, and then PAs or I will answer the posted questions. Okay, so please use this Piazza. Also, I post some resources like lecture slides or lecture videos or some materials for this course on Piazza. Okay, we will not use Blackboard. Okay, so we will use the Piazza for this course management. Okay. Okay, so I will share some. Okay. So can you see my Google Chrome browser? So this is the Korea University Blackboard. So I believe you can see the.
We cannot see it.
Okay. Oh, sorry. Oh, sorry. So I believe you can see now.
Yes.
Okay, thank you. So this is my Chrome browser. Then you can see that this is the content of the Blackboard. And then so I believe you can see my announcement here. So I also make links for Piazza here, and then Zoom Classroom as also course materials. Okay, so if you click this Piazza, then so okay, so I already signed in. So this is the Q&A session of the Piazza. Then you can post any questions or any issues for this course using the new post here. And then so if you click the resources tab, then you can find the lecture slides, videos. A video will be recorded, and then I will also post the recorded videos on YouTube, and then I will also share the YouTube links for these lecture videos. Then lecture notes, okay, design homework solution, and resources here. So you can click the course materials, resources here, then also get access to the resources tab on Piazza. Okay, Zoom is a Zoom link for this course. Okay, please sign up for Piazza. So this is the screenshot of the Piazza for the previous course. So actually the last semester, then you can find that many students post questions, and then I or TAs answer the posted questions. Okay, so please make use of Piazza. So these are some lecture slides posted on the Piazza for the last course. So you can also please check the resource tab of the Piazza frequently. Okay. Okay. So problem is that we are amid of COVID-19 pandemic still. So I provide the online lectures for 2 years, and then still I need to provide the online lectures for the first 2 weeks. So I'm so sorry. So I hope this pandemic pass quickly. So actually for the first 2 weeks, I will provide the online lectures only, but hopefully after 2 weeks, I will provide the in-person lectures, okay? But I believe the problem is that, yeah, so many people, so recently, many people are tested positive. And then I believe some of you or maybe I can be tested positive because the situation is very severe. So I believe some of you can be tested positive. So I believe so that means that I need to provide the online lectures for the separate, not separated, some impacted students. So I will also provide the recorded video for this course, okay? But please attend every lecture because it's very important, okay? So please attend every lecture proactively. And it's very important. Email me immediately if you are tested positive, okay? So I need to know how many students are tested positive. So then if the more than 50% of it's very so I cannot imagine the situation, but if more than 50% of students are tested positive, then we need to stop this course, okay? And then actually more than 30% of students are tested positive, then this course should be provided totally online. So online lectures total, so only online lectures should be provided, okay? So email me immediately if you are tested positive, okay? Okay. statistics. So actually the in-person lectures will be provided during at Ujong Hall of Informatics 604. I hope in 2 weeks we can meet in person. Then this is the Zoom information. Okay. So actively participate in every class. It's very important. And please turn on your video camera. Even though this is the online lecture, so interaction is very, I believe interaction is very important. So please turn on your video. If not, it's like I just tell, teach to the some monitors, to computers, not people, not students. Okay. Thank you. And then this is the grading policy. It's a tentative the rate of the some scores like midterm, final exam 40%, assignment, lab assignment, and attendance. And then exam will be the on-site exam will be. So I plan the on-site exams. Actually, I plan the on-site exam for the last course. That means that the last semester, but we took the online exams for the last semester. But for this semester, I also plan the on-site exams. Okay, so exam will be closed book exam, and then no electronic devices are allowed. Okay, and then also you can answer in Korean or English. So you know this is the English lecture, but using English is my duty, not your duty. So if you have any questions, so you can ask questions in Korean, but I will answer in English. Okay. And then this is a tentative schedule. And then unfortunately, we have 3 holidays for this course. But if we just cancel the all classes for these national holidays, then we cannot meet the requirements for this course. So actually the March 9th is, and then June 1st are the election days. The class will be canceled, but I will record the classes and I will post the recorded classes on YouTube. Okay, so please remember that. So actually the real-time class or the some in-person lecture will be canceled during election days, but I will record lectures and then I will post the recorded lectures for these classes, like the classes for March 9th and June 1st. Okay. So, okay. This is the end of the introduction for this course. So any questions? Okay. So if you have any questions or issues, then you can post questions on Piazza. Okay. And so let's move on to the chapter 1 of the discourse. So network is so slow. So actually I made lecture slides and then I saved this lecture slides on the cloud storage, but the internet speed is very slow. I don't know why. That's the problem of the cloud storage. I think it's faster. So usually the PowerPoint is the size of the PowerPoint file is very large. Okay, I will show the PDF file. So can you see my PDF file, like chapter 1, computer abstractions and technology?
Yes.
Okay,
Yes,
good.
again.
Okay, so let's start chapter 1 of the discourse. So what is computer architecture? So we need to learn about the computer architecture for this course. So what is the computer architecture? Computer architecture means the study on computer systems. So then what does computer system mean? So if we mention computer systems, so that means, so we just mentioned computer hardware. So the computer is composed of software and hardware, and then everyone knows that this is the hardware is just the real computer machine, and then our software or our applications run on this computer hardware. And then usually we call this computer hardware as the computer systems. So if we learned about the computer architecture, that means we learn about the computer hardware or computer hardware structure. But computer architecture also include some intermediate area. So that means the interfaces between computer software and computer hardware. So if we mention the computer hardware, that means it's a real thing. So we can touch our computer hardware, so we can touch our computer machines. But if we mention the computer software, then we cannot touch our computer software. It's just a code. It's just some group of instructions, but we cannot touch our computer software. But if we mention the computer architecture, then computer architecture covers the area of computer hardware and the interfaces between computer software and computer hardware. Okay. Okay. So if we learned about the computer architecture, then that means we study on computer systems. Then what are computer systems? So this slide shows the very old computer systems. It's actually this is the slide show, but I just used the PDF file of our lecture slides. So this is the first IBM x86 computer machine, and then these two pictures are computer machines developed by very popular company Apple. But as you can see, the first shape of the computer hardware is slightly different. So it's slightly different from our contemporary computer systems. And then the Apple developed a very weird looking computer systems or computer machines like this. It's called the Power Mac, maybe. So it's a weird looking. It's actually the shape of this modern computer hardware is very different from the first computer hardware, the first computer machines. But it's very fancy, and then everyone wants to buy these very expensive computer machines. developed by Apple. And then recently we use everyone uses smartphones, and then smartphones are basically computers. Why? Smartphones has CPUs, and then CPUs can execute programs. So programs, what does a program mean? What is a program? It means. So actually the program is a group of instructions. So actually in the syllabus slides, I mentioned that program is the computer hardware is just a machine that executes the instructions. Okay, and then program is a group of instructions. So recently, these machines, like these hardware, these gadgets, include CPUs, like processors, and then these CPUs can execute codes or programs or applications. It's the group of instructions. So as programs run on these machines or gadgets, these gadgets are basically computers. Okay, and then we frequently call these computers as the mobile computer systems, and then sometimes we call this computer system as the pervasive computer systems. Okay, so that means the mobile computer systems. And then traditionally, computer architecture just covers the computer systems that have CPUs. It's a central processing units. But recently, we frequently use some dedicated processors such as GPUs. Okay, so I believe everyone knows, most of you knows that if you want to run the machine learning applications such as neural network applications, we frequently use GPUs because GPUs are good for executing parallel applications. Okay, so actually the structure or architecture of this GPU is very different from the architecture of CPUs. And then recently we use these domain-specific processors for our computer systems because the very popular applications demand high performance or some specific execution models of computer systems. Okay, so for example, I mentioned that, so we frequently use GPUs for running machine learning applications, and then machine learning applications require very heavy parallel computations. So that means GPUs are good for running parallel applications. GPUs are designed for running these, actually the graphics applications, but the native feature of these graphics applications that graphics applications have very repeated and heavy parallel computations. That's why GPUs are widely used for neural networks or machine learning applications. Also, recently we can use some very new processors such as the TPU, is a tensor processing unit, like this figure or this picture. Also, we can use FPGA, it's some programmable processor. So these processes are developed for a specific domain applications. Okay, not the general purpose applications. So what are the general purpose applications? It's some very general applications such as the operating system or some office applications or web browsers, also another some like games. So these are kind of general purpose applications, but we require the specific architectures or specific processes for running specific domain of applications. And then these processors are also studied by computer architecture researchers. Okay, computer architecture researchers are called the computer architect. Okay, so computer architecture also includes the study on domain-specific computer systems like GPUs, TPUs, or FPG. And then also computer architecture includes the computer systems and then very gigantic computer systems. So these pictures show the pictures of Google data center. So what is the data center? So data centers is actually data centers includes the lots of server computers, and then these lots of server computers are connected each other via networking, and to the customers think that, or customer connected to the data center of the Google or Facebook or Microsoft, but they think that, oh, we are using one computer machine. What does that mean? So we can use our desktop computer, like a personal computer, by logging to our Windows or Linux operating system. Then we can use our desktop computer systems. Like this, we can sign into the data center, like Google data center or Microsoft data center. But data center includes the large number of computers. But we can use these large number of computers like one private computer systems. Okay, so computer architecture also study on data centers or server infrastructures. Okay, so actually the most of electric devices we use in our real life includes the processors. Okay, so that means that these devices can run programs. That means these devices are actually computers. So that's why the computer engineering is very popular in this popular recently, and then everyone wants to learn about the programming or some knowledges on computer engineering. So to understand the computer hardware or computer system is very critical, okay? Because the most of electric devices include processors. That means most of electric devices are computers. So this is so actually the authors of the textbook called the recent era is the computer revolution era. So that means that the most of electric devices are computers, and then most of devices run computer programs. Okay, and then these And then recently, we also focused on the domain-specific architectures. So traditionally, if we just mention the computer systems, then traditional computer system includes the CPUs, and then our main program runs on only CPUs. But recently, like these processors, we focus on the domain-specific computer systems. So that means that these domain-specific computer systems can run specific domains of applications. Okay. We also focus on these new types of computer systems. So, like this, we want actually people want to run programs on computers in automobiles. So that means that computers in cars. So many car manufacturers are focused on the autonomous driving, and then for this, in order to build the autonomous driving systems, we also use the very powerful computer hardware. Okay. Also, smartphone, and also human genome project, internet and search engine. So, what does that mean? We just focused on the very popular applications, and then the computer systems are developed for running these very popular or these very specific domain of applications. Okay, so that's why the recent era is called the computer revolution era. And so the computers are pervasive, so widely used by many people. Okay. Also, we can categorize some classes of computers like personal computers. So it's computers for personal use, and then it's a general purpose. So it's like what are the examples of personal computers? So our desktops or our laptop computers. So with this personal computers, only one or several people use the same computer machine. So these personal computers are general purpose, so we can run the wide range of applications. Okay. So what is important? What is critical for the personal computers hardware? Cost and performance. Cost means that the price of computer systems, and then what is performance? The speed of the computer system. And server computers, actually the purpose of server computers is slightly different from the personal computers. So server computers are connected each other via networks, and then many people, large number of people connect to server computers, and then large number of people, and then large number of applications concurrently use server computers. So what are required? High capacity, high performance, and reliability. So reliability means that our data is reliable. So data in the server computers are reliable. So that means that data is not changed, but it is not corrupted. Okay. So, and then supercomputers. What are supercomputers? Actually, we use supercomputers for forecasting weathers, and then so actually the supercomputers are the kind of server systems, and then but these supercomputers are used for high-end scientific or engineering computations. Okay, that's why supercomputers are used for forecasting weathers. Okay. but it's very specific computer systems. You mean the quantum computers? So, I mean, quantum. So one student asked a question. So I believe he or she mentioned quantum computers. So quantum computers is it's very different from the traditional computer systems. Actually, the traditional computer systems use the binary data or some binary systems, but quantum computers use it's a cubic systems. It's very different from the binary numbers or binary systems. So quantum computers is it's a very different. It's not a supercomputers, but it's some new kind of computers. Okay. And embedded computers means that it's very simple computers, and then but this computer system is hidden inside of the device or some systems like smartphones or smart watches or smart speakers. So what is important? Power, cost, and performance. So for the personal computers, what is important? Cost and performance. And then for the server computers, performance is very critical. But for the embedded computers, we need to also focus on the power, because most of embedded systems are usually mobile systems. So that means that mobile system is it's a battery powered. So the power source has the limited power capacity. So that's why the power consumption or energy consumption is more critical for the embedded computers. Okay. So there are many different kinds of computers in our real life, and then also the purpose of these computers are also various. So, and then we need to focus on some specific purpose of these different kinds of computer systems. Like for the personal computers, we need to focus on the cost and performance. And then for the mobile computer systems, we need to focus on the power consumption or energy consumption. Also, cost is very important. So the computers has some very wide range of usage model, and then for the different usage models, we need to also focus on the different aspects of the computer systems. Okay, we have only 6 minutes, so I believe I can ask some these questions. So which processor is better? So Intel Pentium 4 or Raspberry Pi 3B. So actually, this processor works with the 1.3 gigahertz clock frequency, and then Raspberry Pi includes the ARM processor that works with the 1.2 gigahertz clock frequency. So if we just compare the clock frequency of these computer processors, then clock frequency is very similar, but which processor is better? Okay, this is the open question for this course. So another question is that which processor is better and why? So this is the Intel Xeon and the Intel i7 processor. So the purpose of Intel Xeon processor is it's a server system, and then And then i7 is developed for personal use. So which processor is better? So which processor is expensive? Xeon is more expensive, but why? How about the performance? So performance is higher for Xeon. Yeah, right. Xeon has a lot of cores, but the performance of each core is similar to the performance of i7 core, or it may be lower than the performance of single core of i7. But why is it so expensive? Because Xeon includes many cores. And then, how about this? Intel Xeon and then NVIDIA Tesla is a GPU. Which processor is better? This is another open question for this course. So actually Tesla is very expensive recently because of high demand for GPUs. But which processor is better? But it depends on the application actually. So if you study hard for this course, I believe everyone can answer for these questions. Okay. Okay, so I will stop here, and then any questions? Okay, thank you for listening. And then in the next class, I will cover the chapter 1. So this is the introductory chapter for this course. So if you can, then please read the textbook before the next class. Okay. Thank you for your attention, and then see you in the next class.